Hey there, everybody. Welcome back. We are back into Calculus 3. This is more examples on our unit normal and binormal vectors. I'm going to do a problem completely through with T, doing general calculations for everything, and give you some tips along the way. So we're going to use our Helix problem that we did before in a previous section with the butterfly. Which it was 8 cosine t, 8 sine t, and 6t. I just wrote for a reminder of what we need to look for on t and n. To start off with, we need to take the first derivative and divide it by its magnitude. So let's do that. The first derivative is right there, straightforward. Its magnitude, we square these. They both have a 64, sine squared and cosine squared, and then 6 squared is 36. We factor out the 64, and we have sine squared plus cosine squared. That equals 1, so 64 plus 36, because that is 64 sine squared plus cosine squared. Those two right there. There's only one 64. 64 plus 36 is 100. Square root of 100 is 10. So we're just dividing 10 into each of these. These simplify into 4/5 and 3/5. So negative 4/5 sine of t, 4/5 cosine of t, and 3/5. Now to find n, we need this first derivative of the tangent vector. And we'll do that here. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of a constant, that should say 3/5. That's a constant, it's 0. So the magnitude here is pretty easy. On the bottom, because we have the same kind of thing we had with the 64 right here. Instead of having 64, we've got 4/5. But we have a cosine squared and a sine squared. We just get 4/5 on bottom. We're dividing it into the t prime that we just calculated right here. And you'll notice that they all go away nice and neat. It becomes negative cosine and sine, with 0 as the final one. Then I said, okay, what if, this is where I'm stopping, I'm pointing out, if we need b of t in general, go for it, and I will do it on the next page. But if we just need it at a point, like let's say we're looking for at t equals 0, what are my tangent, normal, and binormal vectors? We don't need to do the general form. Which in this case isn't too bad, but you'll see on the next example in part D, it's pretty ferocious. I don't even know if that's a word. Pretty horrendous. So if I plug in 0 into our tangent vector, sine is 0, cosine is 1. We get 0, 4/5, and 3/5. If I plug in 0 to our normal vector, I've got negative 1, 0, 0. And we can find b of 0 just doing the cross product of those two. And that's what we're going to do right now. So this cross this is 0. The j component, remember it's negative. I have 0 minus a negative 3/5, so positive 3/5. But the j component is negative, so negative 3/5. And finally, we've got 0 minus negative 4/5, so plus 4/5. So we've got our 3 unit vectors right there. You can confirm they're all unit vectors if you'd like, but you will find they are. Okay. It stems almost from the 3, 4, 5 triangle. Picture a 3, 4, 5 triangle. And real quickly, you can show that they're all orthogonal if you'd like. I did it real quickly here. I'm not going to walk through the explanation. Pause if you want to check it out. Let's look at the general form of B. So B in general is T cross N. And I'm going to just go through and calculate it. The I component is minus 3/5 times negative sign. So minus and negative is positive. We'll end up with a positive 3/5. As we see there, we do the J component. Remember it's negative. Don't forget that. A couple of you on the test put weird, made them all positive, put negatives on the wrong ones. It was a little weird. Just follow this in order. We're doing the the outside columns now. So 0 minus a negative is a positive. 3/5 cosine t. So 3/5 cosine t, and then the j component is negative. And when we do the first two columns for our k vector or k component, we have plus 4/5 sine squared t plus 4/5 cosine squared t. Again, we have that case where we can factor out the constant and have sine squared plus cosine squared equals 1. So b of t is just that. And we can find it evaluating at 0 that we do get the 0, negative 3/5, and the 4/5 that we got on the previous version. I do want to point out a couple other things. First off, b of t is a unit vector by default without even plugging 0 in. We can do this right here. So 3/5 sine t squared, negative 3/5 cosine t squared, and 4/5 squared. We have the same issue here. We end up with factoring out a 3/5 squared, which is 9/25. And here, that's 16/25. Add them together, we get 25 over 25. Square root of 1 is 1. So b is a unit vector. I've seen a lot of students in the past classes try to do n as the second derivative divided by its magnitude. Don't do it. It works sometimes, as it does here, but it's coincidence. The one where that works on is n of s. That's r double prime of s over the magnitude of r double prime of s. It's not always true with n of t, where it happens to be so in this case. The second derivative is negative 8 cosine and negative 8 sine and 0. We find the magnitude of the derivative, it's 8. When we divide it in, we get negative cosine t, negative sine t, and 0. This is a unit vector, and it's the same normal vector that we had before up here. We had negative cosine, negative sine, and 0. We got that here, but it's coincidence. You'll see in the next problem it doesn't work. Okay. And that's it for this section. I got 2 more videos we're making, 2 more. Another one that's more challenging, and then we're going to look at finding normal planes for this thing. Peace.